So as you can see, about 1/5 of this exam says implement and manage storage. There are 3 sub-objectives underneath that, including configuring access to storage, configuring storage accounts, and Azure Files and Azure Blobs. So in this section of the course, we're going to talk about storage. Now, despite only being worth around 1/5 of the exam score, it's actually a pretty big topic. We do really need to get into a lot of the nitty-gritty when it comes to Azure storage accounts. In my view, a storage account is one of the 3 fundamental services in infrastructure as a service, the other 2 being virtual machines and networking. So let's go to the Azure portal and let's look at the process of creating a storage account. So I'm going to say create a resource. And right off the Get Started tab, storage account is one of the more popular resources, or I could always go to the storage category and say create. Now, over the years, this interface has changed slightly from time to time. We have, at the current time, 6 tabs of the wizard plus the review and create tab. Like any resource in Azure, you must select a subscription, and you must select a resource group for this resource to live. You also must give the storage account a name. As it says in the tooltip, the name must be unique across all existing storage account names in Azure. And so as a result, you might have to get fairly detailed when it comes to naming it, given that there are millions of storage accounts across all of Azure. Now, as most resources, we have to pick a region of the world to deploy it to. And I've got the default here, which for me is East US. It could be different for you. I'm just going to leave it in the East US region. Now, the region that you choose could be important for a couple of important reasons. One is going to be pricing. The region that you choose is directly related to how much you're going to pay. As you can see, there is a price of 2.1 cents per gigabyte for the first 50 terabytes in this East US region. If I was to choose a different region, such as UK, it's actually cheaper, 1.9 cents per gigabyte. So the region of the world actually does affect pricing. Second thing is you want your data to live in a close as possible to the places where you use the data. So if you have your apps and your virtual machines in one region and they access that data in a storage account, you may want your storage accounts to be in the same region. Third, you may have various data residency requirements that you have to live by. So again, different countries and different regions are going to have laws where data must be stored for their citizens. And so if you are, for instance, a European citizen and you're storing the private data of European citizens, then perhaps you may have to store that data in the region of Europe. So you're going to choose region based on a number of different factors. Oh, finally, there might be various features that are only available to certain regions. Microsoft does have the tendency to roll out new types of things to one region before another so that they can be tested out. So if you are dependent on a new feature that is just being released, you may have to choose a region for that. One of the new changes to the UI is to select your primary service. Now, the most normal one is called blob storage. Data lake storage is a special type of storage that's for extremely large amounts of data using big data type workloads. But blob storage is going to be the most normal selection. If you need files or you need something else, tables or queues, you would choose a different option for this. Continuing on this page, this is going to be one of the first options that we have having to do with speed and latency in terms of access. So blob storage is going to be the most normal selection. If you need files or you need something else, tables or queues, UI is to select your primary service. Now, the most normal one is called blob storage. Data lake storage is a special type of storage that's for extremely large amounts of data using big data type workloads. But blob storage is going to be the most normal selection. If you need files or you need something else, tables or queues, you would choose a different option for this. Continuing on this page, this is going to be one of the first options that we have having to do with speed and latency in terms of access. So if we were to choose a premium account, as you can see, it's got recommended for low latency scenarios. Now, the premium account has a much higher per gigabyte charge per month, as well as a lower access charge. So it's going to be, let's say, 0.2 cents for 10,000 read operations versus 0.6 cents under normal hot access. So premium access is more expensive per month, but per gigabyte, but cheaper to read from. So that's just one of these decisions that we're going to make right off the top here. So we're just going to stick with a standard storage account. Now, we do need to talk about the concept of redundancy. So I'll pause the video here, and in the next video, we'll talk about these options for how your data is stored and protected in case of failures. So while we're on the subject, let's talk about redundancy in Azure storage accounts. So I'm in the process of creating a storage account in East US. When I get to the redundancy part of that basics screen, I'm given 4 options: locally redundant storage, geo-redundant storage, zone redundant storage, and geo-zone redundant storage. What does this all mean? So the concept of redundancy is that by default, for free, Microsoft is going to keep multiple copies of my files in case of failure, in case of emergency. So even at locally redundant storage, which is the cheapest and most basic option, Microsoft is going to keep a total of 3 copies of any file I upload into this storage account. So the reason it does that is because hard drives, from time to time, fail. They are spinning magnetic disks, and despite our best efforts in engineering, after so many thousands of hours of active use, the hard drive could experience some type of failure. So Microsoft keeps 2 additional copies of that file so that just that if the hard disk was to fail, then they're able to reconstruct the hard disk based on the files they already have stored elsewhere. The reason they do 3 and not 2 is in the very, very unlikely case that 2 hard drives fail that contain the same files. So this is giving you a lot of redundancy and resistance to failures, server rack and drive failures. So for locally redundant storage, you're going to get 3 copies of your files. This is stored in a data center. So I've chosen East US as my region. This is going to be stored in one region of the East US region in one data center. Now, zone redundant storage would be the next more redundant, the safer option. What this does, it still keeps 3 copies of my files, but instead of keeping them in the same building, it spreads them across 3 different buildings in the region. So these are called data centers. And so zone redundant storage would protect you in case that the entire building was to lose power or to have a flood or some kind of disaster was to strike. Your files are safely stored in a physical separate location. I should point out that not every option is available in every region. So in East US, it has these options. If I go down to North Central US, it's one of the older regions, and we can see that there's only locally redundant and geo-redundant. It doesn't have the concept of zones in North Central US. So as you might expect, then going to geo-redundant storage is even safer still. This takes your data out to another region. So in the case of East US, this can store 3 copies of your data in a single data center in East US, as well as 3 copies of your data in a single data center in West US. So these regions are paired, and so they're basically storing 6 copies of your files in 2 different regions. Now, geo-redundant storage is also not available in every region. So for instance, if you go to Qatar, then you will see that you only have the option for locally and zone redundant storage. And then for the last one, geo-zone redundant storage, that is the safest option of all. It's going to combine the 2. It's going to keep 3 copies of your files in 3 different data centers in a region and 3 additional copies of your files in 3 data centers in the other region. There are costs associated with this. So when we go to the costing screen, we can see, I'll go back to East US, that LRS is costing in that range of 2.1 cents per gigabyte. But if I go to zone redundant storage, that is now 2.6 cents per gigabyte. And I want to go to geo-redundant storage. The prices could change, of course, but 4.6 gigabytes, you see we've now doubled the cost. And geo-zone redundant storage. The last thing I would say about storage is when you get into the geo-redundant storage area, when you've got 2 regions, you have the additional checkbox that allows you to have a read-only access to the second region. So if I was to check this checkbox, I would have a second URL that I could read data from the storage account. So in the case of East US, I know that the data is also stored in West US, and I would have a read-only URL for the West US data in case of emergency. And of course, that does have an impact on pricing too. So when I go to read access geo-redundant storage, then I'm going up to 5.9 cents per gigabyte. I believe it was 4.6 without that second option. So an extra 1.5 cents almost for this option. So redundancy really just makes it much more difficult for Microsoft to lose your files. The higher up you go, the more you pay, but then the more you would expect your files to be perfectly fine and survive for millions of years in Microsoft Azure as long as you pay for it. We've been creating a storage account here in the Azure portal. I'm going to leave the one that we've created in the East US, and I'm going to choose locally redundant storage, and I'm going to hit next, which will take us to the Advanced tab. As the name implies, the Advanced tab contains a lot of security, access, and other settings. Under security, the first setting says require secure transfer for REST API operations. This basically means that you cannot interact with a storage account using unsecured, unencrypted channels. So HTTPS is the only method for interacting with this over the API. This is enabled by default, and you probably should keep it unless you have a good reason for not needing secure transfer. Second option is enabling anonymous access. Now, this is a big security risk. It's happened dozens of times in the past where someone is looking around and they find an open, anonymous storage account or storage bucket for AWS. So it is off by default. And unless you're going to use the storage account for web files like images and MP4 files and JavaScript, unless you're intending anonymous users to be able to access them, I would leave it off. There are two methods of authorization and authentication to get access to the storage account. One is what's called storage account key, and that is on by default. We're going to see in a coming up video about managing your keys. Basically, the key means if you have the key, which is a series of letters and numbers that is very long and impossible to guess, then you can get access to the storage account, the contents of it. So it is what's called claims-based authentication. Or do you want to use Microsoft Entra, which is role-based access control that is handled by Entra? Storage account key is on by default because if you're going to be using applications and legacy applications, this is what's traditionally been supported. In order to use Entra, you have your applications register with Entra, and there's special methods that they're going to need to get authorization. Obviously, TLS 1.2 is the minimum. I believe it's been shown that 1.0 and 1.1 are at this point insecure, so leaving it at 1.2 is perfectly fine. We'll skip over the preview feature. Now, I mentioned in the last video that Data Lake Storage Gen 2 is a different type of namespace. It's an actual hierarchical namespace where you can have files and folders. In a default storage account with blobs and containers, it's a container model, and basically everything goes into the container. Data Lake Storage Gen 2 is more of a files and folders model, specifically for big data analytics, and it has different limits in terms of the amount of data you can store, and it has different access control policies. So we're not going to talk about that much in this course. It just is where you would set it up if you want. You would have to be using, Data Lake Storage Gen 2 in order to set up SFTP or NFS. For blob storage, we have the most important thing here is the access tier. Now, access tiers is an important concept and is a requirement for the exam. And so what we'll come back in the next video and we'll talk specifically about hot, cool, cold, and archive. So while you're in the process of creating your storage account, you can choose what the default access tier is between hot, cool, and cold. So first of all, what is the access tier? Well, I'm going to pull in the pricing page here, and we can sort of see in this matrix the difference between them in terms of pricing. A couple of videos ago, we talked about premium storage being the most expensive to store per gigabyte and the cheapest to access per read or write operation. And this is pricing in terms of 10,000 operations in one unit. So premium really is for when you need the quickest access to a file and you're willing to pay a little bit more to store it. Now, there is actually a way of saving money using the premium plan over the hot plan, but that would involve reading the same file dozens of times per second, 7 days a week, 24 hours a day, all month. So it's a pretty unlikely circumstance. You may be better off using a Redis cache than premium storage in that circumstance. So if you do really need to access a file quickly and frequently, premium storage may be the way to go. Now, hot storage is what we would normally consider the default, right? When you go into the screen, hot is chosen for you. And the text says optimized for frequently accessed data and everyday usage scenarios. So this is sort of a balance between the price of storing and the price of access. So we can see it's, in this case, 1.8 cents per gigabyte per month for hot storage, and additionally, half a cent per 10,000 reads operations and 6 cents per 10,000 write operations. So that is the balance between the price of storage and the price of access. Now, if you do not need to have access to the file as frequently, what is considered infrequent access, you may want to consider cool storage. It gives the example of infrequently accessed data and backup scenarios. Now, cool storage is almost half price per gigabyte per month. So you'll see that it's 1.8 cents for hot and 1 cent for cool. But in order to pay half the price for storage, you're going to pay exactly double for access. So instead of 6.5 cents for 10,000 writes, it's 13 cents. Instead of half a cent for 10,000 reads, it's 1.3 cents. So you pay more for access, but it's cheaper to store. That's why this is good for files where you don't think you're going to need to access it even once per day. Right, the break even between the number of accesses and the pricing per month is probably on the order of less than 1 time per hour, and you're going to save money in the cool tier. So maybe you want to consider choosing cool as the default. Cold is relatively new, and as you can see, you're actually paying way less for storage. So instead of 1 cent per gigabyte in the cool tier, it's 1/3 of a cent per gigabyte in the cold tier. And as we scroll down to see the data transfer, once again, it's almost double. So it goes from 13 cents to 23.4 cents for 10,000 writes, and from 1.3 cents to 13 cents, 10 times for reads. And for this reason, cold may only be good for things you really don't offer access at all. So cold storage is rarely access data and backups. So let's say the scenario is you did a backup of your server yesterday. Well, that might be good to be stored in cold storage because the chances of you needing to restore from a backup from yesterday are very low. But you still may want to keep backups from a month ago, from 3 months ago. You may have a need to keep older backups, in which case the chances of being accessed are extremely low, and you're going to save lots of money storing this in cold storage, around 5% of the cost of hot storage, or 20 times less. But then you pay more if, in that case of emergency, you need to access the file. So that is hot, cool, and cold. Now, one thing that's not offered by default is archive storage. Now, archive storage is very special, in which basically you cannot access archive storage quickly. So this, the analogy will be an offline tape. Back in the 80s, when you used to back up your mainframe, you would back it up to tape, and then you would just, dismount the tape from the tape drive, and that was your archive. So this archive storage, you can move stuff to archive. You'll see that it's another order of magnitude cheaper, 0.2 of a cent per gigabyte for storage, but another order of magnitude more expensive, not for writes, but for reads, you're looking at $6.50 for 10,000 operations, as opposed to only 13 cents or 1.3 cents or even half a cent for hot storage. So this is more than an order of magnitude more expensive for reads. And if you are in a hurry, let's say you use the archive tier, your server crashes, you need to get access to that file, then you're going to pay $65 for a high priority read. So this really is for things that, let's say, things you need to store for government purposes. And if you ever do receive a request from the government to retrieve it, you are going to wait several hours. So it could be a 4-hour plus wait to get this back. So archive storage is for that type of scenario. You are not locked into hot, cool, cold, or archive once you've made a selection. This is just the default. So you could have a mixture of files. Some of them are hot, some of them are cool, cold, and even some of them are archived in the same storage account. There's no restriction on that. So if you are sensitive to the cost of storage, you're looking to save money. Let's say you have a lot of storage and it's all in the hot tier, and you might think about, what can I move to cool tier in order to save almost half the price, or even to cold tier to save down to 5% of the original price. Then consider changing your default, or consider moving your files between these. It's possible to move them from one to the other. Part of this course will have a video on lifecycle access, and we'll talk about automating the movement from hot to cool, from cool to cold, etc. So that is the decision for access tiers. I'm just going to keep this, I'm going to set this to cool access, because the data that I'm using for testing purposes, I don't mind paying a little bit more for access because I'm going to save so much on the storage cost. Let's move on to talk about networking in the next video. All right, let's click next. So on this tab, we're talking about networking. Now, it might alarm you to say that by default, storage accounts have public internet access. That is that anyone, anywhere in the world can access a storage account if they know the public URL and they have the access key if you're using access key authentication. So the analogy that I use is that it's like having a locked door on a busy street. So let's imagine you're a business, you have a door that has a lock. Nobody is going to be able to get in unless they have a key. Also, we can say that you can't break in. There's no way to hack into Azure, at least as far as we know. So if you don't have the key, you're not getting access to the files. That is public access from all networks. Now, let's say that still gives you uneasiness. And so you want to restrict access from the public internet, and you only want access from selected networks. So if you select the second option, then you're going to be able to choose a virtual network. So in this case, I'm choosing VM1 VNet and choosing a specific subnet. And only computers that are connected to that VNet, to that subnet, can access the storage account. So it is more private. So any computer attached to this subnet can access your storage account with the access key, but not the public internet. Now, maybe you do have certain public internet addresses that you do want to have access. So I can add a public internet access address to have access. So this is, again, selected networks, very specific, either address or a range of addresses. Finally, you have the option to disable public and private access. So there's a thing within Azure called private endpoint, and you can set up basically a proxy connection from this storage account to another resource inside of Azure, and those are called private links. So this is the most secure way where you are specifically allowing one resource to talk to this storage account. This is for, again, virtual networks and public IP addresses you've manually added, or the public internet. So that is your role of adding security in terms of networking. Also on the screen is a concept of network routing. Now, typically you would not have to touch this. Microsoft network routing is the default. What does this mean? So let's imagine that you have a resource inside the United States and you have a server in your office in Japan. And that server in your office in Japan needs to access a file from within the storage account inside the United States. With Microsoft network routing, the Japanese computer is going to connect to the Microsoft network in Japan. And then it's going to travel over a private internet network, the Microsoft Global Network, from Japan to the United States to talk to your storage account. With internet routing, this means that from Japan, it's going to travel over the public internet, encrypted, of course, and then enter the Azure network inside the United States. So that's why Microsoft networking is the default. There's not really a great reason to choose internet routing unless you want to, obviously. So that is the networking screen. I'm going to leave the selected virtual networks option open. This means that from Japan, it's going to travel over the public internet, encrypted, of course, and then enter the Azure network inside the United States. So that's why Microsoft networking is the default. There's not really a great reason to choose internet routing unless the Microsoft Global Network from Japan to the United States to talk to your storage account. With internet routing, this is a file from within the storage account inside the United States. With Microsoft network routing, the Japanese computer is going to connect to the Microsoft network in Japan. And then it's going to travel over a private internet network, the Microsoft Global Network, from Japan to the United States to talk to your storage account. With internet routing, this means that from Japan, it's going to travel over the public internet, encrypted, of course, and then enter the Azure network inside the United States. So that's why Microsoft networking is the default. There's not really a great reason to choose internet routing unless you want to, obviously. So that is the networking screen. I'm going to leave the selected virtual networks option open with my own IP address, and that way I can test this from my home, but it's not open to the public internet, even if you have the key. All right, we're moving on to click the next button, and we're coming up to the data protection tab of the storage account creation process. Now, this is important because it's going to allow you to be protected from accidental or malicious deletion or modification of files. So you can see on the screen a number of checkboxes going down under recovery, tracking, and access control. You have the option of enabling an option called point-in-time restore. Now, point-in-time restore is going to keep versions of your files and allow you to go back to any date and time that you specify within the maximum restore point. And so you can go up to 30 days back in terms of point-in-time restore. So let's say I want to be able to go back to any point within the last 21 days in order to restore the container to that earlier state. Now, like it says in the note, that in order to have this, it needs other features such as versioning, change feed, and soft delete. So speaking of which, soft delete is a feature that means when you go to delete a file, it doesn't actually get deleted. It's called marked for deletion. So when you have soft delete enabled, it basically enforces a time period in which you can still restore the file. So even if you don't have point-in-time restore enabled, you can have this soft delete. So with this setting, and it's on by default, I can delete a file and I still have 7 days in the future where I can say, oh, I actually made a mistake and I want to recover that file. The reason this is good is because in case of malicious deletion, a person that goes into your account and deletes a bunch of things, if you can catch it within this time period, then you can easily restore it without having to go to backups and others. So there are 3 options for soft delete. One is for blobs, one is for the entire container. So if someone deletes the container, you can restore it within that many days, and also for file shares. This is on by default. The only thing that this really impacts when you are testing is it's an extra bit of work in order to delete files when they're just test files. So in a non-production capacity, then this is actually more work. Going down to the tracking section, we do have the option of keeping previous versions of blobs. So let's say you have files that change every once in a while. So every 30 days, a particular file gets updated in an update method. Well, having versioning means you're automatically going to have version 6, version 7, version 8. And so Azure is going to store those versions and you're going to basically pay for it. So the more versions of something you have, than the more gigabytes that you're storing. You can control your versioning through data lifecycle, which we'll talk about. The change feed allows you to see when somebody makes changes, create, modification, or delete changes to blobs. So it's basically in a feed that you can then listen to, or you can query, and you can perhaps perform certain actions when changes occur. And finally, under access control, you have this concept of immutability. Now, immutability means that a file can never be altered or even deleted. So this is for important files that once it's written, you never ever want somebody to go and change the contents of that file. This would be like a security log would be a good example of this. So if you're tracking everyone who's logged in or logged out or login failures into your application, you may consider some type of immutable log such that a hacker could not then go and delete the log files and cover their trails. So this is time-based retention policy that applies to all blob versions. So if you have versioning enabled, it applies to all the versions of a file. So you can have this at a container level, or you can have this at an account level, or even at a specific blob level. In order to do this, then you're going to need to have a versioning enabled for this. All right, so that's the different data protection, recovery tracking, and access control features that you can enable for a storage account. In the next video, we'll finish it up. We'll talk about encryption, and we'll create this account. Okay, we're almost done here. We're on to the second to last tab, which is encryption. Now, the big decision here is who are you going to trust to manage the encryption of your data inside your storage account. So all data is encrypted by default, and if you don't change the setting, Microsoft will encrypt your data. This is called Microsoft Managed Keys. It's also Transparent Data Encryption, TDE. What that means is that you don't get to interact with the keys at all. You don't have access to them. You upload your files unencrypted, and Microsoft will store it on the physical hard disk encrypted. And then when you go to retrieve the file, it will automatically decrypt it for you, and you'll receive it unencrypted. So that is a Microsoft Managed Key, and it's the easiest thing to handle. Now, slightly more complicated is the concept of customer managed keys. Some companies insist on having the security keys, access to them. Maybe they have a policy for changing them every so many months. And so customer managed keys means that you create and manage the keys. Microsoft still uses them transparently, so you provide the file unencrypted, it encrypts it using your keys. The way it does this is it stores the key in what is called a key vault. Key Vault is a special Azure service for handling secrets, keys, and certificates. And so you can create a key using the Key Vault and reference that key when it comes time to creating your storage account. So it's not too difficult to create a key in a Key Vault. And then from that point forward, Microsoft will use that key. The default is Microsoft Managed Keys. And unless you really do want to manage your keys and take responsibility for that, then I would suggest you select that. Now, if you do go the way of customer managed keys, additional challenge for you is going to be what services are going to use your customer managed keys. So is it only for blobs and files, but you're going to leave tables and queues using Microsoft's method, or is it for all service types? Again, we're going to leave this as Microsoft Managed Keys. Note that this option cannot be changed after the storage account is created. Do you know what's even better than doing either Microsoft Managed Keys encryption or CMK? Well, that is doing another layer of encryption. That is the infrastructure encryption option. It's disabled by default. You can enable it. And what that does is it takes your file, passes it through this first layer of encryption, and then it takes the resulting encrypted file and encrypts that before storing it to the hard disk. So this is obviously very secure because once let's say someone was to get hold of that hard disk and they were able to reverse the encryption on it, well, then they would still only be getting encrypted files out of that and they would have to reverse it again. So this is going to make somebody's job a lot more difficult. So turning on infrastructure encryption, if that's what you want, is an option. Doesn't cost anything extra. It may add a little bit more latency when it comes to the data that you send to Azure, finally making it to a disk. But if you're really mostly concerned with the data that you're sending to Azure being encrypted, then this is one pretty good option. Now, I have a separate video talking about tags, so we're not going to be talking about that. In the next video, we are going to finally hit the create button and get this storage account created. So come back for that. Okay, we're almost done here. So this is the moment that we've been waiting for. We're on the final tab called Review and Create. As you can see, there's some validation that goes back to check out all of our settings to make sure we haven't made any mistakes. We can review the settings here. if we want to save this and run it as an automation template, and we do have videos in this course talking about ARM templates, this is where we would do that. And we'll talk about that in the appropriate video. So now that it's all past the validation, I'm just going to hit the create button. And all that we've done has now been turned into a deployment and is going to be passed through Azure Resource Manager, and the storage account will be created. So we're going to let that run for about a minute. That didn't take too long, and our deployment is now complete. If I open this deployment details, I can see what goes into creating this storage account. Remember, I attached the storage account to a specific virtual network, and so that's part of the deployment. And if we look at the storage account itself, it took about a minute and seconds to create one for me. Okay, so I'm gonna click this blue Go to Resource button, and that'll load. We can see that provisioning says succeeded. It is a general purpose V2 as we selected, locally redundant storage. Standard, not premium performance in the East US region. So all of the things that we asked for, it's been created. Now, in the videos that follow, I'm going to talk about various features. Now that we have a storage account, we can look at things like Storage Explorer. We can create containers. We can create blobs inside those containers. We can access those. I can talk about how keys work in terms of getting the access to the contents and all that fun stuff. But as of now, we have a storage account created in Azure. So let's keep going. So in our storage account, we can store 4 different types of data. So this, if you recall, was a general purpose V2 storage account. And in a GPv2 account, we can store blob files, which is stored inside of containers, file shares, which is more of a traditional mounted storage that can be shared among multiple servers or computers, storage queues, and storage tables. Queues and tables are not on this AZ-104 exam, so we're not really going to get into it in any detail. We're going to focus in this video on containers. We're also going to talk about Azure Files in this course as well. So let's talk about containers. If I click on the containers option, I'm going to be taken to this containers section. As you can see, I don't have any containers yet. So a container is just as the word sounds, it's like a box. You're going to put all of your files inside this container. You can have multiple containers. And so in that way, you can organize your files according to the type or whatever way you want to organize them. So let's create a container. I'm going to call it first container. That makes sense, right? Now this container is marked as private, and I have no option to mark it as public. Remember, when we created this account, we did not enable the option to have public containers. And this is a security risk if you leave your containers open, but there are some reasons to do that. So I'm going to click create. So it says successfully created storage container. Now, container by itself isn't going to give me anything. I'm going to want to put some files in here. Now, normally, you're not going to use the Azure portal to upload or download files from a storage account. This is just for demonstration purposes, usually. You're going to do it programmatically to put your files in here, typically. So I'm going to click this upload button, and I'm going to put a file into my container. So I'm going to use the drag and drop to put the file there, and I'm going to say upload. Now, this is a 70 megabyte file, one of the videos for this course, in fact. Now, remember, we set the default access tier to cool. So it's showing us as the cool tier. If we wanted to, we could change this to hot or cold tier simply by changing tier. We could even change to archive even though we didn't have the option of setting to default. Now, if you recall, we did turn on versioning when we created this account. So if I was to upload the same file again and overwrite the file, then it's going to create a second version of this file. So if I go into 3 dots here and I say view versions, then we have the current file, and we also have an older version that we can access here. We can also delete the version or make it a current version. Now this file, even though we don't have access to it from the public internet, I did add my IP address as an acceptable access point, so I should be able to access the file. So what do you think will happen if I just copy the URL to the file and try to access it? It is a video, it should download and play. So I copied the URL, I paste it into my browser, I hit enter, and I get an error message. Public access not permitted on this storage account. So this file is not available for access. So like I said, it's the locked door on the street. Even though we have a URL, we don't have access. But we haven't talked about access keys yet, and I'll create the I'll create a lecture about that and, of course, secure access signature. But there is a way to access this file with the access keys, and we'll talk about that in a future video. All right, so what we have is we have a storage account with a first container. We've uploaded a file that's now versioned, and everything seems to be configured exactly as we expected. So in the next video, we're going to talk about access keys and shared access signature. So stay tuned for that. Now, we just saw how easy it was to create a container and upload files into that container. But when it comes to accessing those files, we were getting this message, public access not permitted. We were accessing the storage account by its endpoint, and my computer has access to this endpoint. So how do we go about getting access to this file? Well, first we have to understand this concept of access keys. So if we go back to the storage account, out of data storage and into security, we can look at access keys. When we set up this account, we said we would use access key authentication and not Entra ID. You do have the option of having Entra ID and keys or having only Entra ID. So this keys is a very interesting process. It is in fact a secret that anyone who has the secret and access to the endpoint using networking can have full administrative access to the contents of your storage account. So they can add files, they can delete files, they can read files. If they have the key, they are in. I'm going to show you the key. This right now it's obscured, but if I show it to you, this is a sequence of letters, numbers, uppercase, lowercase symbols that is impossible to guess or hack. So if I had public networking on and you had this key, you could access this storage account. But I don't have public network access on. Now, this is why it's extremely important to keep your key a secret. So this is very much a need-to-know basis. The fewer people that have access to this, the better. Now, what happens if this somehow leaks? Let's imagine you've hard-coded this into some code, and then you publish the code to GitHub public repository. That's happened. And believe me, there are programs scanning GitHub constantly looking for these security keys. So within minutes, if you were to publish code with this key in it and the endpoint, within minutes, this account would be hacked. So what happens? Well, first thing you're going to want to do is void the key. So that's called rotation or regeneration. So as soon as I click this button saying rotate key, this key becomes invalid and no one would be able to access this account using it. Say yes. Now do keep in mind that if you're using this key for other purposes like an application, a script, some programmatic purpose, then everything's invalid. So not only the hackers would be invalid, but legitimate access would also be invalid. So how do we avoid that? Well, Microsoft gives us two keys. The purpose of the key is to allow you to switch to the second key before you regenerate the first. So the sequence of events would be, once you realize this key has been hacked or is you want to regenerate it, you switch all your legitimate programs to the second key, republish them, ensure it's all working, and only then you regenerate the first key. And that way your programs are using the second key. So this is why there's two keys, and this is how you rotate them. There is this ability to have a reminder. So let's say you want every 6 months to change the key or whatever your policy is that you want, then that can be done right from here. So knowing this key is going to allow me programmatically using C# or any of the SDKs, Python, to access the storage account. But how are we going to get access to that video that I uploaded? All right, what we're going to do is we're going to go back to data storage under containers, go into the container. Now, instead of going, I'll say view first. And so instead of taking the URL off of the overview screen, I'm going to choose generate SAS. Now, SAS stands for Shared Access Signature, and it's a more secure way of granting limited access to your blob or your container. Now, you'll notice that it's using the key number 1, as a signing key. You assign a permission, so in this case, it's read-only permission, and it has a start date and time and an end date and time. Optionally, you could provide an IP address even here. And as well, you're going to choose HTTPS only or to allow HTTP access. So I'm going to leave all the defaults, and I'm going to say generate SAS token. Now, there's two components to this. One is just the token. So this token, you don't need to know this for the exam, but it's a series of names and values. And you can see that SP equals R clearly relates to the permissions. And the ST is the start time, and the SE is the end time. So it's sort of embedded what you've selected into this thing. The key part, of course, it's signed. So there's a signature at the end that the key 1 has been used to create this signature hashing, I guess, or of the entire text. what I'm interested in is this URL, blob SAS URL. So I'm going to copy that. Now I go back to the browser and we paste the URL that includes the SAS token and I hit enter. And now a video loads. So we have the read access during this period of time based on this URL. There is a downside to this though. So I've created this SAS token. There is no ability to revoke it. So there's no name for this. It's not saved anywhere. As soon as I leave the screen, this is all gone and forgotten. The key is signed, the token is valid, you're going to be given access. So let's say you've generated an SAS token, it accidentally got leaked somewhere it shouldn't have. How do you revoke it? Well, you have to regenerate the key. So if the key is invalid, then the token signature is invalid. So you go back to the storage account under security, under keys, and regenerate the key. With a regenerated key, this URL should no longer be valid. If I open up a new browser, paste the SAS token, including the signature, it says authentication failed. It's a different error, but the signature is being called out. Signature did not match. So that's the only way you can invalidate an SAS token is by invalidating the key. In the next video, we're going to talk about stored access policies, which will solve this particular problem. Okay, we saw in the video on shared access signature that we assign permissions, start date, end date, perhaps IP address, and the allowed protocols. But once we've created this SAS token, we cannot modify it, we cannot revoke it. So you create it, you give it to someone, and you're pretty much stuck with having this token out there unless you invalidate the key. One way around that is using what's called a stored access policy. So a stored access policy is a way to centrally manage SAS token settings. It is defined at the container level. So we go up to, under containers, we're looking at first container. And we right-click on the three dots, and we look at access policy. So this policy does contain permissions, a start time and expiry time, similar to the way that we would with a shared access signature. So I'm going to call this first policy, and we're going to give it read permissions, and we're going to choose a 1 week policy and say, okay. So this, I haven't actually granted anybody any permissions. I've just created the policy called first policy, and I'll say save. Now, when I go to the file, I can go to the one that I uploaded, and I can say generate SAS. And if I choose the first policy from stored access policy, it's now prevented me from editing the start and expiry date and time, as well as the permissions. I can then generate the SAS token with this. Let's say that I've copied it. Now, if I've given this to somebody and I want to revoke the permissions, I'm not only able to do so by invalidating the key, I can also modify the policy. So if I go back up to the container and I go look at access policy, I can either delete the policy or edit it. And let's say I want to extend the life of this for a few more weeks. So now the permissions, again, have been embedded in the policy. So whoever has the SAS token can continue to use it until the new expiry time. If I wanted to expire it early, let's say I want to expire it 30 minutes ago, then I can change the expiry time to a much shorter period. So now I have editable permissions on the permissions and the time without having to regenerate the token or even contact people. Now, this is best used when you have long-lived policies. You wouldn't do this for just a few hours, but if you had something that is a 6-month policy, that's a long time for something to change, for you to need to grant additional permissions or to change the expiry time. The other benefit, of course, is you can reuse this policy. So you can grant multiple SAS tokens pointing to the same policy and then modify the start date and end date and the permissions all at once. So this is a much more flexible and useful way of managing SAS tokens if you're going to use it to give access to your containers and or your files. So let's go back to talking about security. Up till now, we've been working with access keys, which means that if you have the key, then you pretty much have full access to the contents of a storage account, depending on the network settings, of course. The other type of access is called Entra ID, which is identity-based access control. This shifts the authentication from what you have in terms of the secret key into who you are. And once you've authenticated with Azure, then you would be given the appropriate permissions, which may or may not include access to the storage account or to the container or to a file share. So this is also called role-based access control within Azure. So For general purpose V2 storage accounts, this is available by default. You don't have to do anything in order to enable access control. What you may want to do is disable the account key. So if we go down into this overview screen, we can see under security, it has storage account key access enabled. If I click this, it takes me into the configuration, and I can go down to allow storage account key access. If I set this to disabled, well, suddenly all of the keys no longer work. All of the SAS tokens and the shared access policies no longer work. So I'm going to do that. And Entra ID has, again, for general purpose V2, I don't have to do anything to enable it. Now, there is the concept of defaulting to this. So there are ways of accessing your storage account in the portal, including a storage browser, and when you use the portal to navigate into a container and into the files. Do we switch over to Entra authorization for the portal? I have to enable this because I've disabled the storage account key. So I'm going to save that. I'm going to go back to the overview screen here. So there's a couple of different levels in which you can assign authentication using Entra ID. First is at the account level. And right from this overview screen, we see the menu says access control. We can click onto that. And let's look at the roles. So if we go under access control and roles, we can scroll down and we can see that there's a number of roles. And what we're looking for, I'm going to actually search instead of scrolling. We're looking for the word storage, let's say, to start with. And we're looking for instance, storage blob data contributor, or allows for read, write, delete access to Azure storage blob containers and data. So if you assign this access to someone, then they're going to be able to add files and read files and delete files inside of a blob container in this storage account. So AZSJD new storage demo, assign someone this permission, they will have access to that container, all the containers in the storage account. You can also go down to this individual container, and under properties, there is this access control on the left. And again, we can go to the storage account contributor role as an example. And then they would only have access to this container. So those are, in terms of blob storage, the two levels of access that you have the ability to assign people. Of course, that's not the only role that may have access to this. There are other roles, like reader and data access lets you view everything, but not let you delete or create a storage account or any of the resources. It gives you access to all data. So this isn't the only role that you can assign, but some of these roles are going to have storage account access built into it. So even though I created this account and I created this container, if I go to the overview, it's going to tell me I do not have permissions to this because I've turned off key permission. I've turned on the default for Entra ID permissions, and I have not assigned myself permissions to this. So if I go under access control for the container, and then I can add a role assignment, I can choose the storage blob data contributor role as an example. I can choose myself, and I say review and assign, and say review and assign. Now when I go under view my access, I can see that I not only administrator in this management group, but I'm a blob data contributor for this resource. Now this could take a few seconds to propagate, but eventually when you go back to the overview screen, you'll see that you do have access to list the contents and even to view the contents of this. You see the authentication method has been set to Microsoft Entra. So as we've seen, using the access key is definitely the easier way of getting access to a storage account. It used to be historically the way that it was done, but there is some pitfalls. If you lose this access key that allows other people to have full control over your storage account, you do not have really good ways of controlling the access key. You can use the shared access signature or stored access policies, but that is not perfect. Changing the key can be a little bit of a hassle sometimes. So moving to a Microsoft Entra for authentication and control of your storage account, while more difficult to implement initially, does give you finer grained control and maybe better long-term control over the contents of your storage accounts and your containers. So this is the lesson on Microsoft Entra. All right, so now it's time for you to try some of these actions within a lab environment. So attached to this video is a Udemy lab, and it is going to allow you to do some work against a storage account. So first thing we need to do here is we need to install the Azure Storage SDK, and you can see the code up here to install it. If I click play here, it does a bunch of installation work. You may already have things installed, or maybe you need more stuff to be installed. Next, we're going to import that SDK into our project. Now, as far as the connection string, I have pasted a connection string here, but you're going to need your own Azure account. So if we go into the Azure portal, I have a sample account here, and we're going to go under access keys. And each of these keys, we're going to choose key number 1. You can see there's a connection string. So you're going to show this, and you're going to copy the resulting connection string, and you're going to paste it into this connection string. Now, I've done it here. I'm going to recycle my account key, so don't worry about that. So now we have a connection string and a client. Now, the first thing we're going to do in our storage account is we're going to create a container. So we have a container named demo-container, and we're going to call the SDK create container command to create it. We're going to output that it's been created. So if I run this, it says demo container created. I can go back to my Azure portal under containers, and I can see demo container was indeed created. Great. Now we need to create a sample file. Now this project will create a sample called sample.txt, and we'll write some hello world type text into it, and then use the upload blob function in order to upload it. So we can open the files for the Jupyter runtime, and I can run this code, and it says file uploaded. That was pretty quick. It takes a second. Actually, I can probably I won't even have to do that. Sample.txt was indeed created as part of this project. And if we go back to the demo container, we can see sample.txt was uploaded. Great. Now we want to download it. So one of the things we can do is we can get a list of blobs from text is part of that. And if I run that, we have created a container, created a file, and uploaded if you follow along within the Jupyter notebook attached to this lesson.